Okay, hi, this is a continuation of TYS Topical 2010 to 2019 for the periodic table chapter for pure chemistry. Okay, this is number 11, or if you don't have the same TYS as me, this will be the 2013 question 21. So the symbol of an atom of element J may be written as this. To which group does element J belong? Which group? So you have to look at the valence electron. So this one is mass number of proton plus neutron. So this one is the smaller number must be the proton number, which is the number of electron. So from here, you can write down the electronic configuration. Electronic configuration is just 2. That means the valence shell is full. Valence shell is full. That means it must be group 0. So this is group 0. Okay, so in order to find out which group, you've got to write down the electronic configuration and then find out the number of valence electron. In this case, the valence shell is full, 2. First electron shell can accommodate 2 electrons. So valence shell is full, only group 0 elements have this. So this is actually helium. Okay, the elements W, X, Y, Z have increasing proton number. They are all in period 3 of the periodic table, but are not necessarily next to each other. So they are all in period 3, not necessarily next to each other. So we look at the periodic table, period 3. So this is period 1, only hydrogen, period 2, period 3. But they are increasing proton number, meaning that they are all arranged from left to right, but not necessarily next to each other. So it may not be sodium, magnesium. It could be sodium, aluminium, phosphorus, and chlorine. Okay, we don't know. Which statement is correct? So if we look at it, chloride of Z is ionic. See, 1, 2, 3, 4. W, X, Y, Z, right? Z is ionic. So look at it. Is it possible the fourth element, W, X, Y, Z, the Z is ionic? So period 3, okay, fourth element. So 1, 2, 3, 4. So it could be silicon. It could also be phosphorus. It could also be sulfur, chlorine, or argon. So any one of these can never be ionic because they are non-metal. Yeah. Actually, it cannot be silicon because it says already W, X, Y, Z. It says that W, X, Y, Z are not necessarily next to each other. That means can be next to each other. So it can be next to each other is silicon. But if it is not next to each other, it could be phosphorus, sulfur, chlorine, or argon. So anyway, any one of these cannot be ionic because they are all non-metal. Oxides of W and X are both amphoteric. Oxide of W and Z. So if you look at this W and Z group, period 3, right? Period 3, the only amphoteric is aluminium. Aluminium oxide is amphoteric. The other one, the other two will be zinc and lead. Zinc and lead, they are not here. So there can only be one amphoteric. Cannot be 2. So B is wrong. C, W and Y contain the same number of shells of electrons. Yeah, correct. Because all of them are in period 3. Period 3 means 3 electron shell. So same number of shells of electron lah. That's why the answer is C. If you look at D, X and Y could be in the same group of the periodic table. So how can it be same group? It cannot be in the same group. Okay, same period. Same period. That means it's horizontal. Same group means vertical. Cannot have two of this W, X, Y, and Z to be in the same group. Cannot. So D is out. Okay, number 13. Okay, the diagram shows arrangement of electrons in the atoms of 4 different elements. Which element is the most reactive with water? Most reactive with water must be group 1. Group 1 is the most reactive one. So group 1 because 1 valence electron. This is group 2. This is group 8 or group 0. This is group 1 as well. So it's either A or D. A or D. Which one is more reactive? Both are in group 1. So group D is more reactive because group 1, the reactivity increases as you go down the group. So as you go down the group, the number of electron shell increases. That's why this one is more reactive. Okay? Because group 1, the reactivity increases as you go down the group. Another explanation would be this one, the valence electron is very far away from the nucleus. So the attraction forces is weaker. When the attraction forces is weaker, it's easier for this atom to lose the valence electron to become positive ion. This one, the attraction is stronger. So it's harder for this atom to lose the valence electron to become positive ion. So this one is more reactive. Which oxide can be reduced by hydrogen? Which oxide can be reduced by hydrogen? Actually, this one is from the metals chapter. Then you have to look at the reactivity of hydrogen and the metal. Hydrogen is above copper in the reactivity series. So that's why you can use hydrogen to displace the oxygen from copper to oxide. Yeah, so you can actually do like that lah. Sorry, H2. Then you get Cu plus H2O. Okay, oxide can be reduced by hydrogen. Okay, elements X, Y, and Z are all in the same period of the periodic table. Same period. Same period again means same number of valence electron. So X forms, which order do the elements appear in the periodic table? X forms an amphoteric oxide. If it says form an amphoteric oxide, this one must be, where would it be in the periodic table? This one, remember this X can either be ZAP, which means zinc, aluminium, and lead. So if you look at the periodic table, ZAP, they are all at the middle. Okay, so you have zinc, you have lead, and then you have aluminium. They are all at the middle. Solid X does not conduct electricity, which means that your X must be non-metal. Okay, have to annotate like that. Z forms an ionic oxide. What forms an ionic oxide? Ionic oxide means basic oxide, means that your Z must be a metal. Z must be a metal. So you have metal, you have non-metal, you have amphoteric. Okay, the order the elements appear in the periodic table. This is all in the same period. In which order do the elements appear in the periodic table? There will be Z, because they are all say in the same period. So from left to right, which is Z, okay, metal, and then X, which is amphoteric, and then Y, which is the non-metal. Okay, from left to right. Okay, using your knowledge of the halogen and their compounds, which statement is incorrect? Solid astatine is white. So you know the color, right? The color of the halogen. As a halogen, as you go down the group, the color becomes darker. So this is the mind map, the page 4 of the mind map. So you can see that the color becomes darker as you go down the group. As you go down the group, the colors become darker. So astatine is the last one. Astatine color is black. Astatine is black. So must memorize all this color. Solid astatine is not white. So look at other options. Bromine displaces astatine from a solution of potassium iodide. So this kind of thing, write down. Bromine displaces astatine from a solution of potassium astatine, KAT, plus bromine, Br2. Then you get displaces astatine. So astatine is alone. So it's like this. Is it correct? Yeah, because bromine is more reactive than astatine. Then silver astatine is insoluble in dilute nitric acid. Silver estatite is insoluble. Actually, this one, silver estatite, insoluble. Silver estatite. Now, estatite is a solid. It is insoluble. Actually, this one we wouldn't know. Okay, there's a question mark. Then if you look at hydrogen estatite, it's a covalent molecule. Hydrogen estatite. Yeah, it's a covalent because non-metal and non-metal. Yeah, but what we are very sure is solid estatine is definitely not white. Okay? So this one we are not very sure. But this one we are sure that it is incorrect. Yeah, so you choose your best answer. The one that you are most sure with, that's why it's D. Okay, number 17. Which property is not typical of transition metals? The transition metals are basically those metals without a group in the periodic table. Okay, like copper. Yeah, so they form colored compounds. Yes, colored compounds. They have high melting points because all of them are metals, high melting points. They have low density. No, this one low density is actually group 1, the alkali metals, because they float on the water. They show variable oxidation state. Yes, for example, copper. Copper, you have copper 1, copper 2. So oxidation state +1, +2. Okay, so this one is on the properties of the transition metals. Okay, number 19. Number 19, the position of the elements W, X, Y, and Z are shown in the outline of part of the periodic table. Which statement is not correct? So element X will react with element Y in the ratio of 1:1. This one, X, this is group 2. So for example, group 2, this is group 2. And this one is group 7, VII. So group 2 and group 7. Group 2, so for example, beryllium. Okay, beryllium is 2+. This one, for example, fluorine is -. So if they react, you cross multiply, become beryllium F2. So how can the ratio be 1:1? It is 1:2. Okay, so this one should be 1:2. Yeah, that's why C is wrong. Let's look at other options. All the elements are reactive with the exception of element Z. Yeah, all are reactive. Group 1 is reactive because only need to lose 1 valence electron. This one, group 2, is also reactive but not as reactive as group 1 because this one I need to lose 2 valence electron. This one, very reactive because only need to gain 1 electron. This one, no need to gain, no need to lose, so it's not reactive. An atom of element X has a greater mass than an atom of element W. X and W, it's X greater mass. Of course, proton number increases, so the mass number increases. And then D, only one of these elements will form an ion with a negative charge. Yeah, only Y will form an ion with a negative charge. Yeah, it will form an ion with a negative charge like this. Okay, number 19. The statements refer to a number of elements in the periodic table. For which pair of elements is each statement correct? Form colored compound. So these are basically the transition metals. Actually both are transition metals. All these are the transition metals properties. Okay, so you can actually refer to the last page of your mind map to look at all the properties of your transition metals. Okay, these are the properties. Yeah, they are all here in the last page of the periodic table mind map. Okay, form colored compound, have so you got to look at the periodic table, see which one is transition element. So if you look at it, chromium, titanium, both. So this one, both will form colored compound if you look at A. Variable oxidation state, aluminum is not a transition, so out. Manganese, yes. B, yeah, definitely, all these are transition elements. C, calcium is not transition. And so C is out. D, magnesium is not transition, so it is out. Which property of aluminium suggests it is not a transition metal? Low density. So all the transition metals, they have high density. Okay, then number 21. Which pair of elements, when reacted together, would give the most violent reaction? Most violent reaction would be the group 1 and the group 7. The group 1 and the group 7 are very, very reactive. Because group 1 only need to lose 1 electron. Okay, 1 valence electron to become stable. This one only need to gain 1 electron. That's why both are very, very reactive. These two also group 1 and group 7. But lithium less reactive than cesium. Iodine also less reactive than fluorine. This one also. Yeah, in fact, all of them are group 1 and group 7. Just that you have to choose the most reactive group 1 as well as the most reactive group 7. Okay, element Q has the following properties. To which part of the periodic table does Q belong to? So, this one you have to work backward. So your Q must be 3 plus, your Cl is minus. Then you get QCl3. This one, same thing. You get Q is 2 plus because your SO4 is 2 minus. Yeah, so from here you know variable oxidation state, plus 2, plus 3. That's why it's transition element. Number 23. The diagram shows part of the periodic table. Which row is correct? Can donate or share an electron W. Yeah, it can gain, lose. Can donate? Donate means transfer. Means gain or lose. Okay, and it can share as well. Hydrogen. React with water. Why? Okay, so it's W and Y. Okay, P, Q, R, and S are elements in the periodic table. Which statement could be correct? Q and R form as elements at the positive electrode during electrolysis. Positive electrode is the anode. Okay, which means that these two are the anion. P and S both conduct electricity. Metal. P has a higher melting point than S. Okay, this one, there are many possibilities. Q displaces R from aqueous solution containing R minus ion, which means that your Q more reactive than R. And then both of these are actually halogen because the charge of the ion is negative. So based on this, okay, let's look at A. P could be sodium and S could be lithium. Higher melting point than S. Yeah, that is group 1. As you go down the group, the melting point actually decreases. P could be sodium, S could be lithium. P could be sodium. Actually, it should be the other way around because lithium is above sodium in group 1. So actually, lithium has a higher melting point than sodium. So this one is wrong. It's the other way around. Okay, lithium is above sodium in group 1. Then if you look at the B, Q could be Br2. It's anion, correct? And R could be I. Q and R. Yes, Q and R. Q is more reactive than R. That means bromine is more reactive than iodine. So it's correct. Anion. They are anion and then they are halogen. R would be paler in color than Q. R, where is R? Okay, R would be paler in color than Q. Nope, because Q more reactive than R. Means that Q is above R in group 7. So which means R must be darker compared to Q. R must be darker than Q. So this is wrong. S exists as diatomic molecule. S exists as diatomic molecule. Where is S? P has a higher melting point. S, this one is a group 1. Group 1, how can group 1 be diatomic? Wrong. Yeah, because it says both metals already conduct electricity. Metals cannot be diatomic. Okay, 25. Some properties of elements in the same group of the periodic table are listed. Which properties show an increase as the group is descended? Descended means going down. Go down the group. Okay, as you go down the group, charge of the ion doesn't change. Number of outer shell electrons doesn't change. Okay, number of outer shell electrons is period. As you go across a period, then it will change. It will increase from left to right. Number of proton, yes, and total number of inner shell electrons. Total number of inner shell electrons. That means total number of electrons. Yeah, so it will increase. So what do you mean by that? What? Okay, I think probably some of you have questions. What do you mean by inner shell electron? So if you look at group 1, if you look at group 1, lithium and sodium, as you go down, it's like this one, right? So lithium, electronic configuration 2-1. This one, 2-8-1. Inner shell means not valence shell. Inner shell means not valence shell. That means in this case is the first electron shell. In this case, would be the first and second electron shell. So you have 2, you have 10. That's why the total number of inner shell electrons must increase as you go down the group. Okay, number 26. Part of the periodic table is shown. So which of the elements W, X, Y, and Z would react together least violently? That means the least reactive. So it cannot be W and X. W and X is the most reactive. Cannot be Y and X. Y and X are the most reactive. This one is a most reactive in group 1. This one is the most reactive in group 7. So the least reactive should be these two, W and Z. Because this is least reactive among the halogen. This is least reactive among the group 1. So these two. Which of the properties listed will a typical transition element have? High density, high melting point, variable oxidation state, form colored compounds. Actually, it's all. Okay, all right, so that would conclude Pure Chemistry 2010 to 2019 TYS Topical for the periodic table chapter. Remember to do all your annotations. Thank you, bye-bye.